Okay, this chapter is about post hoc tests, and as we said previously, when you do an ANOVA, when you're comparing multiple groups, although that's a very powerful test, one of the drawbacks to it is it cannot figure out where the differences are. You have to run another test called a post hoc test. And to illustrate this example, I'm going to go back to these PSAT scores. If I were to hypothesize something about these PSAT scores, my null hypothesis would be that all four of these groups are equal to each other. And what I want to know is there a significant difference between those? The initial ANOVA would determine, yes, there is a difference. But what that difference is could be any number of things, because it could be that the senior scores are greater than all three of these groups. It could be that the seniors are greater than the juniors are greater than the sophomores are greater than the freshmen. It could be that the freshmen and sophomore are equal to each other, which are less than the juniors, and seniors, which are equal to each other. When you consider the number of possibilities using greater than, less than, and equal to, and you have this many groups, you can see how many different possibilities you can come up with. That's why we want this post hoc test to do this for us, so we don't have to try to figure it out. It'll do all the work. When the ANOVA is calculated, it uses an F-score, and then that F-score is also used. It kind of like does a two-tailed test. So there's one or two different ways that can happen. Generally, what we will do is let it do what's called a pairwise comparison, and it does all the comparisons of, for example, in this case, freshmen versus sophomores, sophomores versus juniors, juniors versus seniors, seniors versus sophomores, freshmen versus juniors, freshmen versus seniors. It does all those comparisons automatically. And that's called a pairwise comparison. And the other type is called a non-pairwise, and that means that we have to do a little bit of planning ahead of time based upon our literature review about where we think some differences may exist. And we can tell it to compare juniors and seniors versus the average of freshmen and sophomores. And we can plan those out ahead of time. I might compare the seniors to the other threes. I might compare just the freshmen to the other three groups. For example, if I'm interested in having a freshman center, I can tell it to compare just that group to everybody else, so that I'm not requiring it to run a bunch of stuff I'm not going to use. There's different types of tests, and the author lists in your book a number of different types of post hoc tests, ranging from liberal to conservative. And I'm going to jump ahead a few slides. And this is basically the range. A Fisher's test is one of them. It's called a very liberal test. Scheffé is a very conservative test. When you look at the post hoc test, one of the things questions you need to ask in your mind is why they used the test they did. For example, if you were reading the study and the author used Fisher's LSD test, you should ask yourself, why did he use such a liberal test? If they'd used a more conservative test, what would have happened? Would they come up with a different result? A liberal test increases the chances of a type 1 error, but that reduces the chances of a type 2 error. A conservative test increases the chances of a type 2 error, but decreases the chances of a type 1. So there's always a trade-off to these. And as we said previously, if you remember back to our discussion of those, a type 1 test is always more damaging than a type 2 test. So, which one is okay? Well, if you're going to make a mistake, then you want to make a mistake of the type 2 type. So my personal opinion is you want to move towards a more conservative test. The most common one that you'll see is this Tukey's, or also known as a Tukey's HSD. It seems to be about the right balance between liberal and conservative tests, and it also is the most common one. When you look at these post hoc tests, they should always tell you what test they're using. If they don't, that should raise a question in your mind. If you look in your book as you're listening to the video, or go stop the video and go get your book, there's different ways that they'll do this. If you look at excerpt 12.18 on page 295, and this is in the 5th edition of the book, it has a table that describes these differences between this PDSR identified non-panic, PDSR identified panic, and SCID. And they describe to you down at the bottom of it in the note what this means. And basically by using these indicators, these letter indicators, they're saying anything with a B is equal to each other. But those are not equal to A. So in this group you can see that the mean score for this PDSR non-panic is lower than these other two groups. But those other two groups are equal because their letters are the same but both have a B. If we look at 12.19, here's a different way of doing this. We have three different groups, cluster 1, cluster 2, and cluster 3. And they're being compared on three different measures, PEM, NEM, and CON. So they're doing pairwise contrast. And what they're telling us is that on this first score, cluster 1 is greater than cluster 2, and cluster 2 is greater than cluster 3. On the NEM, cluster 2 is the highest score, which is greater than cluster 3, which is greater than cluster 1. And it's important to realize that it's possible that some of these could have been equal. So for example, it's possible that on the PEM on the first line, it might have been 1 is equal to 2, but they're both greater than 3. So there's not always going to be a greater than or a less than. Sometimes you get different things. The third one on 12.20 provides a slightly different way of doing this. And they have some bar graphs, and they tell you up at the top what post hoc test they use. They use one called a Tukey-Kramer post hoc analysis. And they tell you in the description in the paragraph at the top which one is greater than the next one. So for example, it showed all three conditions, control, counting backwards, and counting backwards in 12s differ from each other. It's important that they included that because if you're to just look at that bar graph and the way that the whiskers overlap each other, you might think that there's not a significant difference between those. So there's a case where it's important that they do provide you some information. There is something else called a planned test that is sometimes done, and then basically what happens is they just skip the ANOVA and they go straight to the post hoc analysis, although that is fairly rare. In your notes or in the course content, there is about 3 articles and a set of questions that I've included in there. Basically, I want to show you some examples of these. This first one is this self-competence, and in here they describe this one-way analysis of variance, and they're measuring something about the ethnicity in terms of some different measures like self-competence, etc., etc. And they also tell you the means and standard deviations and where some of the differences are. And what they tell you is, and here's the post hoc test that they used, is that there was, for the ethnic group differences in the perception of self-competence, there is significant results for 24 of the 48 pairwise comparisons. So now they have this long verbal description of all the different comparisons. The question I asked is, why didn't they include the table? Well, with 24 of the 48 pairwise comparisons, the table would be enormous. There's no way that you could possibly get that to fit on something like this. So that's one example. Here's one about Alzheimer's. And on this example, and this is actually the last one, it tells you that they've done an ANOVA and they are using Tukey's B procedure. And they have determined that, for example, on the age group, that these three are statistically the same age. And the way that you tell is because these letters are the same. These three have an A. This one has a B. So that one is significantly higher than these other three groups, which are equal to each other. I'm going to stop here and come back to this one because there's something important I want you to see about this video. So I'm going to pause here and start another video.